Welcome back, everybody. I hope you had a nice cup of tea or coffee. We'll go on. Our next speaker is Bjorn Backeberg. He's a researcher and advisor at the Software Center of Deltares. Bjorn, please.
Thanks, Anita. Good afternoon, everybody, and thank you very much for the opportunity to present our part of the C-Scale project today. So, as Anita mentioned, my name is Bjorn. I'm in the C-Scale project. I'm in charge of Work Package 4, which is the user-driven co-design of the Federation. So I'm going to present a little bit about how we do this, what it's all about, and also some opportunities for the community to get involved. So if you bear with me, try and get us through this. Right, I thought it might be useful to quickly remind ourselves of the objectives of C-Scale. So we plan to deliver a federated compute and data infrastructure offering Copernicus and Earth observation data. And the idea is to really deliver a seamless user experience where all of the complexity around compute and storage, resource provisioning, orchestration in the cloud, and all of those kind of things is abstracted or hidden from the user. And in addition to that, we really want to provide access to optimized low-level data or higher-level analysis-ready data, depending on your end user. And where the analysis-ready data is not available, we would like to provide on-demand solutions so that users can generate these analysis-ready data. And really, it's, as Christian mentioned earlier in his presentation, it's really about designing this federation with the user communities. And we've targeted the research communities who, through use cases, will co-design the federation by deploying their use cases on the federation and thereby testing it, piloting the services and the solutions that are available, and feeding back to the providers, refine it, and ultimately help provide or create a federation and services on top of that federation that are useful for the community. So Christian already presented this, and these are some of the federation principles that we're adopting in our approach. So really what we want to achieve is to have homogeneous and standardized interfaces to access resources. We want to ensure that all of the Earth observation data is fair and across the providers. We want to make it easy for additional providers to join the federation. And in doing so, these providers have to sort of follow European Open Science Cloud policies when it comes to operational and technical requirements. And this in turn allows these providers to leverage some of the EOSC core services in terms of accounting, AAI, etc. And in doing so, we really hope to maximize interoperability across the whole landscape between the providers and the end solutions that are provided. So what does that really mean for the end user? So really what we want to what the user should be able to do, he doesn't have to worry about dealing with infrastructure details in terms of setting up computing pipelines and all of that nonsense. All he wants to do is he wants to go to where the compute and data resources are and generate meaningful results. That's what an end user wants to do. So all of the complexity behind the compute and storage resources is again abstracted away, and we want to make sure that everything is homogeneous so that me as a user, when I access C-Scale, I don't know whether I'm computing in Poland or in Spain. Doesn't matter. Right, so, and in delivering the C-Scale Federation, we really want to take a user-driven approach. So the whole federation design is driven by user requirements, so we can guarantee the delivery of an environment that satisfies user needs. What often happens is the infrastructure providers and the users, they work in isolation of each other, and then you deliver services that the infrastructure providers might think are useful to the users, but in the end are not. So we want to avoid that. So we derive our user requirements by deploying mature applications, in this case we call them use cases, on the C-Scale Federation. And by doing that, we basically test the usability and the functional design of the federation. And really the idea is for the use cases to provide feedback to the infrastructure providers on, for example, ease of use of the resources, effectiveness of the support, appropriateness of the technology, speed of access to the resources is a big deal. And then ultimately, we want to provide feedback on the resultant usability of the application that has been deployed, whether or not it works as expected, whether or not it works at all. And then ultimately we'll report back on sort of missing functionality or resources that still need to be put in place for the federation to really work, and then overall provide some indication of how satisfied we are as users with the federation. So here really is your opportunity to get involved as a community. So what we're asking is there's a call, this is a general call to the community to help us create a compute and data infrastructure with platform services that are really useful for the community here. And I'm stressing the word useful here. So there's a couple of ways you can get involved. The first one is you can just join the discussions. So we've set up a discussion forum, an open discussion forum. You can pitch ideas, you can ask questions, you can do whatever you want. There's moderators on the community forum and we will respond to your questions. So by all means, that's the least overhead way of getting involved. The other way is you can submit a use case. So as Christian mentioned, we currently have an open call for use cases at the URL here. And it's a really low overhead submission procedure. So there's literally just an MS Microsoft form where you submit a few answers to questions and off you go. After it gets evaluated, of course. But why would you want to apply for a use case? So some of the things that are in it for you. So if your application is successful, you get access to compute and storage resources, and that's including GPU resources that are part of the project. You will benefit from the new technologies and platform services that are being piloted on the Federation, for example, OpenEO is one. By working with the infrastructure providers, you might be able to increase the technology readiness level, that's TRL, of your application, so making it more robust and etc. And also, by working with the providers in an open federation, you'll be able to avoid the vendor lock-in by, for example, working only in Amazon or only in Azure or only in Google. So the open approach really could make your applications more cloud agnostics and easier to reuse, essentially. And then because we have a federated approach and we have significant resources at our disposal, the idea is that it should be easy to scale your applications to really achieve planetary scale analytics. And what I always quite like about the European Open Science Cloud landscape is that we could really benefit from cross-disciplinary services and solutions. For example, the high energy physics communities or the astrophysics communities, they've spent a lot of time in this big data space, and we could argue that the Earth observation community has got a little bit less experience with the big data compared to other communities, and we could stand to benefit from collaborating with those. Then obviously part of the call is that you receive support from the infrastructure providers to deploy your application, so it's not all up to you. And lastly, a benefit is you can register your application or any services that are derived from your application in the EOS portal, and thereby engage sort of a broader group of stakeholders, attracting people to what you've done and maybe reuse some of your solutions. Oh, and did I mention it's free? So it's sponsored by the project. So all of the resources that you get are project sponsors. So here's the offering. So first of all, we offer compute and storage resources. So the total capacity available to all of the applications are listed here. So it's a significant amount of resources, is all I'm going to say. And it's provided by this list of infrastructure providers that are part of the Federation or part of the project at the moment. And you will get access to Federation services to manage user access, to monitor service availability and reliability, and also to measure compute and storage usage. But then in addition to that, you also get access to scientific tooling, applications, customized virtual machines, or other sort of platform compute resources. There are platform services that allow you to manage complex workloads, to train AI models, to deploy automated clusters. You can run containerized applications, or you can perform interactive analyses with notebooks. There's also a range of data management services available to you to transfer, to catalog, to cache and federate data across multiple compute and data sites. And again, to highlight that you have access to a network of experts to help you work in this environment. So we're working at the project inception. We'd already identified, I think, 6 use cases. Here are some of the examples. We're currently working on deploying these use cases on the Federation to test its functional design. We have a use case on drought forecasting, which Frederic just presented. We have the forest recovery capacity use case, which Jan van Besselt and Milutin presented in the Return project. We have a use case on land surface changes, which can derive how the land surface has changed between whether or not it was water at some stage and now it's land. It's the top middle one. In the bottom middle one, we're working towards estimating reservoir water capacity. The top right one is wetland water stress classification using machine learning algorithms. And then this bottom right here is a ports and aquaculture early warning system for the Mediterranean, or in Greece, in fact. I just wanted to spend some time talking about the aqua monitor example because for me this is really one of the more challenging ones in a sense, because the whole aqua monitor thing, which basically it's the land surface changes one. The whole aqua monitor example was built in Google Earth Engine, and it really is a really powerful tool to analyze land surface changes, and it relies significantly on the Google architecture, almost exclusively. And one of the things that we're doing within the context of this project is we want to be less reliant on Google, for example, for our analytics. So we're porting the Google Earth Engine we're porting this functionality to C-Scale by leveraging what's available in OpenEO platform. And the really nice thing about this is it's like the first alternative that I've seen, at least, which could be an alternative to Google Earth Engine in terms of the functionality that it provides. And it's really ideal from a user perspective. We don't have to worry about the infrastructure provisioning. There's one vision related about all of the EO data. We don't have to worry about parallelization too much. And it really has been a pleasure to communicate and collaborate with the infrastructure providers related to this tool. And that, I should say, is true for all of the use cases across the project. So what I wanted to say now is that in deploying all of these use cases, we're actually, what we're doing is, as a community, we're populating the PaaS layer, or the platform as a service layer, because what we're doing is we're deploying our use cases, we're figuring out what sort of tooling we need to really make them work. And then ultimately from that, we can derive some services that other people might be able to use. So it's really a community-driven or community-developed PaaS layer, which I think is quite promising in terms of delivering something useful for the community. So with that, just one final call to please join us in this project and submit your call for use cases. And if you have any questions, please feel free to contact myself or either Raymond and Anetta. They're also very good contact points. Happy to take any questions. Thanks.
Thank you, Bjorn. Any questions from remotely or from the room? Yes.
Not quite sure where I should stand.
Thanks for your talk, Raymond from Surf. I'm just wondering, maybe for also the online audience, can you say a little bit more about the process upon submission and use case, the timelines involved,
right,
how they will be contacted, etc.
Right. So if you follow the link to the use cases, basically it'll take you to a Microsoft Word form that you have to complete, or you could do it online in a Microsoft Forms thing. That gets submitted. It's really a couple of questions that you have to answer, not a huge proposal you have to write. That gets sent to us. We, as a consortium, evaluate the proposal or the application, and that should take around 2 weeks, and then we will give you an answer, and then we'll start working with you. If your application is successful, of course, we'll start working with you into determining, what compute resources, what data resources you need, and which provider will be helping you in implementing your application. And all in all, I think it should take something from like 1 month from submitting your application. Well, we have cutoff deadlines, right, every 2 months. So the next cutoff deadline is November. So end of November, we'll analyze all of the applications, and then within 2 weeks, you'll receive notice, and hopefully within a month, you'll be able to access resources. That's the vision.
So if I understand correctly, if you submit before the end of November, you might be online by the end of December.
Correct.
That's cool.
Yeah, great.
Okay, thanks again, Bjorn.